Hello students, welcome to Scholastic classes. In today's video, we will be solving a few questions from the model question paper of SAT examination. And these questions are from section 4 of the model question paper of SAT. First, we will solve question number 24. Question number 24 is a problem of geometry. So if in the question number 24, you have to find which of the following is an equation of a circle in the xy plane with center 0, 4 and radius with end point 4 by 3, 5. So this is a circle and this is the center which is 0, 4, and let's say this is the radius which is 4 by 3, 5. So this is what we have. First we have to find the length of the radius. So the length of the radius will be equals to, so the r square will be equals to 4 by 3 minus 0 whole square plus 5 minus 4 whole square, that is the x component minus this x component, because this is the r or radius, this point is 0, 4 and this point is 4 by 3, 5. So to find the length of this radius, so this is the x component and this is also the x component, so x2 minus x1 whole square plus y2 minus y1 whole square, that will be the r square. So r square will be equals to 25 by 9. And if you already know the equation of a circle, that is in the form of x minus h whole square plus y minus k whole square is equals to r square, where h, k is the locus of the radius. This is locus of radius, and r is the length of radius and h, k are the locus of the radius. H is the x component of locus of the radius and k is the y component of the radius. So here, as the center is 0, 4, so h, the value of h will be 0, so x minus h is equals to locus of radius, locus of, this is locus of center, this is locus of center. So x minus 0 plus y minus 4 whole square, which is equals to r square, that is 25 by 9. So we have got x square plus y minus 4 whole square is equals to 25 by 9. This is the equation of the circle. X square plus y minus 4 whole square is equals to 25 by 9. So option A is correct for question number 24. Coming to the next question, question number 25. Question number 25, you can see an equation. The equation is h equals to minus 4.9 t square plus 25 t, where h represents the height of a ball. So the equation above expression the approximate height h in meters of a ball, and t represents the time, that is t in seconds, after it is launched vertically upward the ground with an initial velocity of 25 meter per second. So this is the initial velocity is 25 meter per second. After approximately how many seconds will the ball hit the ground? So basically what is done here, we are throwing a ball from the ground and it is again coming back and hitting the ground again. So when we are throwing the ball, first, that means at the initial times, then t is equals to 0, and we have to find when the ball again hits the ground. So at that case h will be equals to 0. So when the ball hits ground, that means its height is 0. So this is the initial when we are throwing the ball, then t equals to 0, and when the ball is hitting the ground, then h equals to 0. So putting the value of h as 0, we will get 0 equals to minus 4.9 t square plus 25t. Taking t common, we can write 0 is equals to t into minus 4.9 t plus 25. So this is 0 is a multiple of these two terms, t and minus 4.9 t plus 25. So t can be equals to 0, or minus 4.9 t plus 25 can be equals to 0. So minus 4.9 t is equals to 25 means t equals to 25 by 4.9, which is equals to 5.1. So the height can be 0 at 2 points when t equals to 0. That means the initial time when the ball is just throwing upward. So the point of initiation, at the point of initiation the height of the ball will be 0, and after 5.1 seconds of throwing the ball it will again hit the ground, so the height will be again 0. So the question, that is how many seconds will approximately after how many seconds will the ball hit the ground again, will be 5. So the nearest option of 5.1 among these 4 options is option D, that is 5. So this was solution for question number 24 and 25. In the next videos we will be solving question number 26, question number 27 and so on. So if you have any doubt or any queries, you can feel free to call us in this number 9836 793076, or you can send us email at shourabsirclasses@gmail.com. Thank you.